homework assignment and the first module and stuff. I'm going to be putting more information up for Module 2 and stuff. Module 1 has a lot of little topics, so there's a lot to do. So looking at your homework, basically, I'm noticing that we've got a few issues that I really want to reiterate on things. So sign numbers. So that's the positives and the negatives. So there's different rules for adding and subtracting versus multiplying and dividing. Like everything else in math, we've got to try to make it complex. Like terms, what they are, what they really mean, what you're going to be dealing with stuff like that. Order of operations, you're pretty good with those, but I really want to reiterate it. Same with absolute value. And then we might look at some stuff with fractions and stuff in this too. But we'll start with our sign numbers. And I like to think of things visually. So sign numbers. And that's kind of like the very first question that you had. You were adding a whole bunch of different numbers. So if I'm doing adding and subtracting, and if you really want to think about it, think of it as a staircase and you're chasing like a 2-year-old going up and down the stairs. So for example, so can I say simplify? Or they might say evaluate. Evaluate and simplify are essentially the same thing. Evaluate means that I'm going to get it down to a number, so I won't have any variables or letters in the thing. Letters, generally in algebra, things can be the same at the end, but looking at that, we'll give you an example. So let's say I say 5 plus 2 minus 8 plus negative 3 minus 5. So I've got positives, negatives. Really, anything, I always think of the sign always goes with whatever follows. So this is, if I'm looking at the separate terms, I have a plain old 5. My second term is 2 or plus 2. My third term would be negative 8. Okay, minuses and negatives morph into each other, so that would be my third term would be negative 8. My fourth term is negative 3. They kept it in parentheses, so I definitely see that it's a negative 3. And my last term is a negative 5. Which I don't really like, so I'm going to make it 15. Okay, so if I'm thinking of a staircase, this means I start from ground level. Okay, ground level. And my first thing is I went up 5 stairs. Okay, if I want to actually draw the stairs, I could. And then I'm going up another 2 from there. So, plus 2. How many stairs would I be up right now? I'd be up a total of 7 steps. And then I'm going to go down 8. But, so I went down 8, minus 8. I would actually be below the ground because I was only 7 steps up, so I'm at minus 1 right now. And then I'm going to go down another 3. Okay? And then another 15. So, okay, you can make this your 7 steps. So, I was at minus 1, so then minus another 3, so negative 4. Down another 15. Okay, so this will equal negative 19. Because I'm below ground, I didn't ever get back up. That's just how I think of adding and subtracting. Subtracting, really, I'm thinking of it as a negative number that I'm adding together. Okay, so then multiplying and dividing, of course, to make math fun, has to give you a little bit different directions. So, multiplying and dividing. Now, the multiplying and dividing is actually a little nicer on the fact that it's memorizing set rules. You don't have to think through it so much. It's a given, set rules. Okay, so if I have a negative, everybody knows this. Remember, a dot is for multiplication. We're not going to use the x because it really gets confusing because we're going to use x to replace stuff or as placeholders, meaning a variable. So dots are going to be multiplying. Parentheses next to each other could be multiplying as well. So this is positive times a positive. Okay, it's positive. That's not too bad. If I have a positive times a negative, like I adding a debt, and that stays negative. Okay? And it doesn't matter the order I multiply things, because like 2 times 5 is the same thing as 5 times 2. So the next rule is a negative times a positive. Still, there's only one negative, same negative. Okay? The one that's a little quirky is the negative times the negative. They cancel each other out. It's like I took away a debt, and that becomes positive. So multiplying, the division works the same way. Multiplying, dividing rules are set. Don't get it confused with the adding and subtracting, because adding and subtracting, you have to reason it out, and that goes with thinking staircases for me, or some people like to think of number lines. So if I do dividing by, remember, I can write a positive, I can do divided by this way, okay? Or, same thing, positive fraction just means divided by. That's the same thing, and that equals positive, same rule. Multiplication, division, same general things are opposites of each other. So if I do a positive divided by a negative, or write it as a fraction, the plus over a minus, you still have a minus. Okay? A minus divided by a plus, minus over plus, still equals minus. And a negative divided by a negative, or negative on top of a negative, kind of funny, equals positive. Okay, so those are just your general rules. So you have to pay attention to whether you're multiplying or adding things, and then the rules change depending on what you have. So that's what I wanted to make sure I reiterated with signs and numbers. Going back, what was the next topic that I decided that we were going to cover? The like terms. Like terms. So like terms. Okay, for that I actually need to make the definitions. I need to know what a term is in that. Term is just basically any mix of numbers and or letters that are separated by a plus or a minus. I also have to note, so note, any minuses so if I give you 6 minus 18xy plus 4. If I'm looking at it, the terms I have, there are this, term 2. Now, when I talk about the second term, I'd say 3y because I always assume things are positive unless they tell me otherwise. This would be problem with minus 18xy, but my term is a negative 18xy. And this is my fourth term. So that is just what a term is. Then we get specific about what a like term. On each of the letters. So we will do an example of it. So if I give you 5x plus 3x minus 4 y x minus 7 plus 2. Okay, so if I'm looking at the problem, First of all, how many terms do I have? I have 1, 2, 3, 4, 5, 6 terms to start with. I'm not worried about which ones I'm going to end up with, but I have 6 to start with. So don't think ahead of yourself too far. So whenever I'm looking for like terms, I always start from the left, just like everything else. If I jump around, I will lose something. So I'm looking at my first term. With this term, what are my variables? In this case, it's x. So I'm looking at for something that just has an x. So I look at the next term. This has an x, but it also has a y squared. So it doesn't match exactly the letters and exponents as the first term. The next term has a y squared and an x. So it doesn't match the number of letters and stuff as the other term. And then I have the 8x, which does match because it only has an x, and it's the same as the first one. So I'm going to mark that the same way. And while I'm at it, I can combine them to combine like terms. And we're going to do, you just combine the coefficients. So I'm looking at what my coefficients are, so 5 plus 8. And if I had more terms, I'd do that too, that were the same thing. Gives me the 13x. And I forgot to tell you, once I find one that matches, I have to still check the rest of the equation, or the rest of the expression, and none of the other terms match with my x. So that's why I kind of stopped with the green. Then I look at, I still have more mess up in my problem that I haven't dealt with. So then I'm going to look at my next term. And my next term, like here, is my 3xy squared. So for this one, my letters that I have an x, which doesn't have an exponent, it really has an exponent of 1. And I have my y, which I need a y squared. Okay, so I'm looking for y squared and a plain old x. So I look at the next term. I have a y squared and a plain old x. It actually does match, even though they're in a different order. Usually we keep things alphabetically, but if they're trying to mess with you on a problem, they're going to put them in whatever order they want. Remember, you're just looking for the same letters, same exponents on the same letters. So that matches with this. Notice how that minus sign stayed in the circle, plus sign is in the circle or the box. And then I keep looking. So the next term that isn't already accounted for is this -7y squared. Okay, the y squared matches with my terms that I've got circled, but it doesn't have an x, so I can't combine it with anything. And the plain old 2 doesn't have any letters at all, so that can only go with plain old numbers as well. So I'm looking here. I have 3 minus 4. So it's like I went up 3 steps and then went down 4. Where did I end up? 1 step below the ground. So minus, you can put a 1. Sometimes it won't put the 1. It'll be invisible. And then x, y squared. Okay, and then I look at the rest of my problems, the rest of my terms. I have, I'll do a box again, -7y squared. Everything else to the left of it is already boxed, so I was just looking at that too, and there's nothing else to go with it, so those are just going to be brought down exactly like you see them. And now, since I've looked at everything, I've mushed together what I could. This is actually the final answer. I can't do any more because they don't match their letters. Okay, so don't try. So that I don't want you to worry too much about the front, and that we're looking for the same letters, same exponents on each one of the letters. Okay, let's go back and see my next topic that I determined was order of operations. Very, very important is order of operations. And that's the exact same order because order does matter, and then you can get to the same answer. So you want to have the same directions as everybody else. Different teachers teach it differently. I think I was taught it originally as please excuse my dear Aunt Sally, which you still have to know where that's coming from or what it really means. More modern teachers have been teaching it as PEMDAS. So P. What's a math term that starts with P that we're going to see in algebra? This means parentheses. Okay, that means if you have a problem with parentheses, you're going to have to work to the innermost parentheses and work your way out, get rid of them before you can do much else. So when I say parentheses, I'm going to add something else to it. This is, you may have to distribute. Because if you, in your parentheses, you don't have like terms, but there's something in front of the parentheses, you distribute to get rid of it. I did put a PowerPoint in Module 2 so that you could see another way of distributing it to lessons, just distributing. So we might put a video together on it too, but for right now, I'm going to leave it with just the PowerPoint. So if I had a problem and I had parentheses, they have to be done first, and I can't move until that particular parenthesis is gone. Okay, so after parentheses, PEM, so E. And that word for E is not equation, though it's tempting, is exponent. Okay, exponents are a shorthand way of doing multiplying. And really, it's you're multiplying whatever the exponent is attached to, that as many times as the exponent. So, example. If I give you 2 to the 4th, that 4 is the exponent. Okay, this is your exponent. And that really just means I have 2, and I need to see 4 of them. And it's multiplication between them. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? Same thing works as if there's a variable term. So say I have parentheses, and I have 3x, because I'm not being creative, to the 3rd. Okay. Because I don't like that, but we'll leave it. Meaning that 3, the exponent of the 3, is attached to the parentheses, so I need 3 sets of parentheses. Okay, what's in the parentheses? A 3x. Okay, so now if I'm solving it, or simplifying it, it's 3 times 3 is 27. And then I have how many x's you have 3 of them. So that's just that. And it's not going to be an actual number because I don't know how big x is. X is just a placeholder saying some number that I'm going to multiply by. Okay, please excuse our pen. So M. This is important. M and D. I do them together in the same color because they really are the same thing. They're kind of opposites of each other, but they can undo each other. So multiply and divide. And people tend to forget this little bit. It's literally left to right. Any multiplying, any division. Very important, left to right. Okay, so if I was looking at a problem, like in the homework, I have one where I switched the orders of things. If I'm reading the problem and I have division before the multiplication, I really would do the division before the multiplication. If multiplying comes first, it's not as difficult because you think of multiplying first, you do the multiplication first. It's literally as you approach it left to right. We're going to do an example on this at the bottom of this. And then before we finish, we have the A and the F. Okay, that's still left to right, but it's not as critical, especially if you think of sign terms and keep the negatives with whatever's following. Okay, so let's look at an example and make it kind of ugly. Because it's no fun if we don't do something ugly. So, say I give you, and they're going to tell you simplify. Evaluation. All right, so these are still parentheses. It just means that I might have something else inside of it, and I always use parentheses to match them up with something else. Actually, I did one in X. I apologize. That's supposed to be a 4. I want to evaluate. All right, so if I'm looking at a problem like that, before I freak out, I already start looking from the left to the right. I see a bracket right here. But I find the mate of it on the other side, which is right there. So I'm looking inside between there. I can use Post-it notes to cover up the rest if I need to, and then I'm going to focus my way inside. So I'm looking inside those brackets. They're the same thing as parentheses, and I say, okay, I'm going back in there. What's my order of operations? Parentheses. Then I see if I have any more parentheses, which I do, which is that 4 plus 3. So that is where you have to start. Okay, so 4 plus 3 is 7. Now, if you're kind of crazy and want to see everything that you did, I literally leave everything else, only because I'm crazy. Okay, and notice how I left those parentheses right around that 7. That's because there's stuff attached to it. And I have to remember that math people, being lazy, don't like to tell you that this really means 2 times. There's little time signs there. 7. So I still have to do those parentheses first. So 2 times 7 is 14. Okay, and now since there's nothing else attached to it, it's a single term, I don't need the parentheses anymore. I do need the rest of the problem now. And you don't have to show all of the steps. I really just want to show you my thought process when you're looking at it. All right, so I'm still stuck with, after every single step, I always go back to the order of operations and say, okay, have I completely dealt with that step? So parentheses still 5. Exponents, I don't have any. Awesome. So then I go to the multiplying and dividing, literally as whatever I hit first. So 14, no multiplication or division. Negative 100 divided by 20. I stop right there because I see divided. So a negative divided by a positive is a negative. So this becomes negative. 100 divided by 20 is 5. Okay? So that did this. Okay, and then I write the rest of the fallacy because I'm crazy about it. Parentheses 14. Notice how the old stuff just did the right split. Exponents, there still aren't any. Multiplication or division. So now this time I'm doing a negative 5 times 5, which is negative times positive is negative. 5 times 5 is 25. And then I write the rest of the problem. Okay. Parentheses, still have to do those brackets. So, but this time I'm doing 14 minus 25. So it's like I went up 14 steps and then went down 25 from there. So I will be at a negative 11. I'm below ground. I have to keep the brackets because I have stuff attached to it outside. Okay, so now I can actually do, remember there's a times sign here. 5 times negative 11, positive times a negative is negative. And 5 times 11 is 5. Okay, if they would have put the, if I would have been back in this step, so be careful. The division can sometimes be done before the multiplication. So I know if you want, we can do more examples, but I don't really think we need to. You'll get lots of practice with order of operations. So, and then the last thing is the absolute value. Absolute value. Those things, absolute value. My way of thinking of it is distance from 0. On a number line. Okay, I also think of them as like a field goal. And I know if somebody is trying to get a field goal, they have to kick the ball a certain distance. So I can remember distance that way. As a side note, these are parentheses. They're just a grouping symbol. They just get you to focus. Okay, so absolute value is actually it's a distance. You're not you're calculating a difference. So if I'm, but same thing with order of operations, absolute value has to be done. Absolute values do have to be done first, just like parentheses. So I wanted to look one that you had on your homework. Okay. So for example, I'm pulling it off of my head. Okay, usually I wouldn't have that fraction bar really just means divided by, so this is like a double divided by fraction. So I wouldn't normally do that. But for in this case. So order of operations tells me I have to do parentheses first or absolute value. So I'm really focusing, I have to do these first. Okay, so looking inside there, I still go through order of operations. Do I have any more parentheses? No. Do I have exponents? Yes. So this I have to think about as 3 4 times. So 3 times 3 times 3 times 3, okay, which is 81. Okay, and 5 to the third. That minus sign is not attached to the exponent. It's a minus sign. Okay, so this is just 5 times 5 times 5, which is 25 times 5, which is 125. So really what you have is absolute value of 81 minus 125 plus 14 over 8 and 9 divided by 6. All right, so I still have to deal with those absolute values. So I'm thinking about what is 81 minus 125? It's like I went up 81 steps. When it's down 125, so I'm going to be below ground. So it's a negative 44. Okay. And now I have the absolute value of negative 44. So how far is negative 44 from 0? That just becomes 44. Now I have 44 plus 14, 8 times 9 divided by 6 squared. Okay, so now I'm going to look at, I can deal with the top and then the bottom if I really want to. Being ones that are parentheses, the bottom being another. I have to do my exponents. So this is, looking here, 6 squared. This is 6 times 6, which is 36. Okay, so I'm going to look at what I have on top. Is 44 plus 14 over 8 times 9 divided by 36. Okay. Order of operations, I'm going to do on bottom, so multiplying. So it's 8 times 9 is 72. So I have 72 divided by 36, which becomes 2. Add and subtract on top, so add 44 plus 14 is 58. I am not going to make that an improper fraction, but I do know that 2 actually does go into 58. So what is 2 divided by 50? 58 divided by 2, and say go to school if I have to, 58, 2, and 29. Now, if 2 didn't go into, if the answer I had didn't go, the bottom didn't go into the top, I would just leave it as an improper fraction, but in this case, I guess this is 29. Okay, so absolute value, same thing as parentheses, only in the order. 3 questions we're talking about distributing, which there's more on in the lecture, the lesson part for Module 2, because distributing is multiplying stuff in, and then the GCF is factoring, which we're going to do some probably, I think it's week 4 that we're going to look into factoring, more factoring specifically. So those ones I wasn't so as concerned about. It was really these main problems that we were looking, that I'm noticing in the homework-wise. So for Module 1, if you have any more questions, please make sure you ask them, email me. I'll respond as quickly as I can. Let me know what you need to be successful. Module 1 has a lot of stuff. The rest of the weeks won't be as many topics in 1 week, so it should be a little less overwhelming. As always, if you start to panic or think that you're not getting something or it's getting too confusing, that kind of stuff, please let me know and I'll try to give you resources and let you know some other stuff. There's actually one more thing that I do want to tell you about. There's another resource besides Khan Academy that you might like. Check out www.mathtv.com. What it is a bunch of videos from a teacher's teacher, so it's somebody teaching college students how to teach math, and it has some great examples and walks through topics. It's not as searchable. It's a little setup different than Khan Academy. I don't have the embed links, so that's why I'm not using them. It'll show you different people explaining the same problem, so some of them you'll find different teachers that you like better, and it's a good resource. So you're looking by topics there on the left-hand side. You'll see as you look at it. So let me know if you have any questions like that. But that is another good resource for finding examples worked out for you. I think he tends to be a little less confusing over Sal from Khan Academy. All right, so let me know if you have any questions. Email me. I can't fix anything if you don't tell me where your problems are, or don't tell me that you're being stressed because I don't get to see you. I'm relying on you letting me know when the stress is getting too high or the confusion is setting in. All right, so we'll see you soon.